In this video, I will show you how to create a RESTful Web API using Spring Boot. We will use MySQL Database and we will perform CRUD operations, which are create, read, update, and delete. First, we need to create a new Spring Boot project, so we can create it using Spring Initializer. Let's go to the first link. So we will create a project using Maven. Let's select Java. Let's select the latest version of Spring Boot. Then here let's provide the group ID. So the group ID is the name of the owner of this application. Then let's provide the artifact, which is the name of the application. We can call it Store API. Then we can provide the project description. Let's select jar and the version of the JDK. Then we need several dependencies. So the first dependency is Spring Web. Let's select it. So this dependency allows us to create web applications, RESTful applications, and MVC applications. It has an embedded server, which means that we don't need to install any server. Then we need to install more dependencies. So the next dependency is DevTools. So this is the dependency that we need. It allows us to restart the application automatically each time we make a modification. It is optional, but it is very practical. So let's select it. And because we will use MySQL, we need the MySQL driver. Then we need Spring GPA. So this dependency allows us to read and write the data in the database using Java objects. Let's select it. And to validate the submitted data, we need also another package, which is the validation package. So these are all the dependency that we need. Now let's download the zip file. So let's click on Generate. Then let's save the file. Let's save it on the desktop. Now let's extract this file. So I will extract it in the Documents folder. And in the Documents folder, I have a folder called Spring Projects. So let's select it. Then OK. Now let's open the project using Eclipse. So it is under Documents, into the folder called Spring Projects. So it is Store API, let's select it, then Finish. So this project contains a Java class that is available in the Java folder. So this is the main class of this project. It contains the main method, so we can run our application from this class. So let's make a right click, then run as, then Java application. But here we have this error, failed to configure a data source. So to fix this error, we need to configure our application to connect to the database. So let's go to the resources folder. Then here we have this file, application.properties. Then let's add the following properties. So we need the driver class name, and because I will use MySQL, so this is the MySQL driver name. Then this is the URL of the database. So here we will connect to a database called StoreDB, and we need to create it. This is the username. I don't have any password. We can use this property to display the SQL queries on the console when we run the application. Then we can use this property to update the database each time we update our models in this project. Now we need to create this database. So here I will use MySQL that is available with exam, and we can create a new database using phpMyAdmin. So let's click on admin. So these are the available databases, and we need to create a new one. So let's click on new. And here we need to create a new database called StoreDB. Let's click on create. And here we can see that this database has been created. Now let's save the file. And let's run the application again. So now we can see that the application is running correctly and it is accessible at this port number. Now let's create a new model that allows us to read and write the data in the database. So let's create a new package. Let's call it models. Then let's create a new class. So this class will be our model. Let's call it product. So because we are using DevTools, we can see that each time we update the source code, the application restarts. So because this class is a model, we have to decorate it with the annotation entity. With this annotation, a new table will be created and will be called product. But I want to call it products. So let's add another annotation. It is called table. Then let's define the name of the table in the database and we can call it products. Now let's import these annotations. So because the two annotations belong to the same package, we can delete the name of the annotation and we can replace it with star. Then let's define the different fields of our model. So we need the product ID, the name, brand, category, the price, the description, and the date. And because the ID is the primary key, we have to decorate it with the annotation ID. Also, it should be auto-incremented, so we have to add generated value and the strategy is identity. Then here we can see that the description is of type text. If we don't add the colon annotation, then description will be of type varchar. Now let's import the date class. Then we need to create the getters and the setters. So we can create them automatically. So let's make right click, then source, then generate getters and setters. Let's select all the fields, then generate. And here we have the getters and the setters. Now when I save this file, a new table will be created and will be called products. This is because in the configuration file, we used this property, update. This means that when we update the models of this project, the database will be updated. So let's save this file. And we can see that the application has restarted and this is the SQL query that is used to create the products table. Let's take a look at the database. So let's click on the database again. And you can see that we have this table. Let's take a look at the structure. And here we can see that we have the ID, which is the primary key, and also it is auto-incremental. Then we have the description, which is of type text. So for the moment, the table is empty and you can fill it with some data. So let's click on SQL. Let's delete this query. And let's write the query that allows us to fill the table. So here I will insert into the products table the product name, the brand, category, price, description, and the date. And here we can see that the date is the current date. So here we have the different values. And to execute this query, we can click on Go. And here we can see that we have 10 new rows. Let's click on Browse. And you can see that the table is not empty anymore. Now let's create a repository that allows us to read and write the data in the database. So let's create a new package. Let's call it repositories. Then let's create a new interface. So it is an interface, it is not a class. And let's call it products repository. So this interface should extend the GPA repository interface. So here let's add extends GPA repository. And GPA repository requires two types. the type of the model, and the type of the primary key of the model. So in our case, the model is this product model, and the type of the primary key of this model is integer. So just here, let's write integer. Let's import the interface. And let's save the file. So this is all what we have to do, and we don't need to implement this interface because the Spring GPA will implement it for us. So now we can use this interface to read and write the products in the database. Now let's create a new API controller. So let's create a new package. Let's call it controllers. Then let's create a new class. Let's call it products controller. So this controller is an API controller, so we have to decorate it with the annotation REST controller. Then let's define the endpoint that allows us to access to this controller. So let's add the following annotation. It is a request mapping, and between parentheses we have to provide a string, which is the endpoint. So this controller will be accessible at the URL /API/products. Of course, we can change this URL. For example, we can delete /API. But because this is an API controller, I will use /API at the beginning. Now let's create a field of type products repository that allows us to read and write the products in the database. Then to request this repository from the service container of our Spring application, we have to decorate it with the annotation autowired. Then let's create the method that allows us to read the products from the database. We can call this method getProducts, and it will be accessible at the URL /API/products using the HTTP GET method. So it will return a list of product objects, and here we will return repo, which is our repository.findAll that allows us to read all the products from the database. So let's import the annotation and the different classes. Let's save the file, and let's read the products using Postman. So let's create a new tab. We will send a request using the HTTP GET method. Then here we have to provide the URL of the server. So we have to write localhost :8080/API/products. Then let's click on send. And here we have the data. So we can see that we have a list of objects. Every object corresponds to one product. So this is the first product. And this is the last product with the ID 10. Also, we can see that we have a success response from the server. Now let's create the method that allows us to read the product by ID. We can call this method getProduct, and it returns a response entity of product. So if we find the product, then we will return the product with a success response. If we don't find the product, then we can return not found. So this method will be accessible at the URL of the controller, but also we have to add the product ID in this URL. So it will be accessible using the HTTP GET method, and just here let's add parentheses. Then the name of the parameter, so we have to add brackets, and let's call this parameter ID, which is the product ID. Then we can read this ID in the parameters of this method. So here we have a parameter called ID, which is of type integer, and we will read it from the path. This means from the URL. Then we need to read the product from the database having this ID. So let's create an object of type product. It is equal to our repository value.findById. Let's provide this method with a product ID. But here we can see that we have an error because this method returns an object of type optional, but here we have an object of type product. So just here let's add dot or else. So we can see that or else requires a parameter which is the default value. So if we find the product in the database, then product will be this product. Otherwise, null will be the value of this product. Now let's check if the product is null or not. If the product is null, this means that we did not find a product with this ID in the database. So if the product is null, then we can return not found. Otherwise, we can return a success response with this product. So just here, let's add the product. Now let's import the missing classes. Let's save the file. And let's read the products by ID. So here let's add slash the product ID, 2 for example, then send. So here we can see that we have only one product with the ID 2, and also we have a success response. Now let's provide the ID of a product that does not exist in the database, 20 for example. And here we can see that the response is 404, which means not found. Now let's create a new model that allows us to create new products. This model allows us to receive the product details from the user, and it is called a DTO model or Data Transfer Object Model. So let's create a new class in the models package. And let's call it product DTO. So this model will be similar to the product model, but we don't need the ID because the user is not allowed to define the product ID, but we need the name, the brand, category, the price, and the description. Also, we don't need the date because the date will be obtained from the server. So here we have the product name, the brand, the category, the price, and the description, and the name is required. So if we don't provide the name, then the error message will be the name is required. Also the brand is required, the category is required, the price should be a positive number, and the description should be between 10 and 2000 characters. Let's import the missing annotations. And because all the annotations belong to the same package, we can delete this name and let's replace it with star. Then let's generate the getters and the setters. Let's select all the fields, then generate. Let's save the file. Then in our controller, let's create a new method that allows us to create new products. We can call this method createProduct. It will be accessible at the URL of the controller, which is /API/products, using the post method. It requires an object of type product DTO, which is the model that we created, and we need to read this object from the request body. Also, we need to validate the data of this object, so we have to add the annotation valid. And if we have any validation error, then the validation errors will be available in this object, which is of type binding result. Then let's check if we have any validation error. So we can use this object to check if we have errors or not. So if we have any validation error, then we will read the different errors from the result object and we will store it into this variable. So this variable is of type list of object error. Then we need to create another variable which is of type hashmap that allows us to store the field name and the error message. And for every error in this errors list, we will read the error and we will store the name of the field and the error message into this map that will be returned. So if we have any error, then we will return a bad request, and in the body of this response, we will add our map. So if we have any error, we will return a bad request. Otherwise, we need to save the product in the database and we need to return a success response with this product. So we will create an object of type product and we will set the name, the brand, the category, the price, and the description using the received data that is available in product DTO that we have just here. And for the date, it will be the current date. Then we need to save this object in the database. So let's use our repository. And we need to call the statement repo.save, and this is the product that we need to save in the database. Then let's return this product. So just here, let's return a success response that contains the product. Let's save the file. So we can open a new tab to send the post request. So we will send a post request. And we will send the request to /API/products. So we will send the data in the body of the request. Let's select row. And we will send a JSON object. So we can send an empty object to see the server response. Let's click on send. So here we can see that the status is bad request, and here we have the different validation errors. The name is required, the category is required, and the brand is required. So here we can see that we have no error message for the description. So to fix this, let's annotate the description with not empty. So let's write the description is required. Let's save the file. And let's send the request again. So this time we can see that the description is required. Let's fill all the fields. Then send. So this time we have a success response, and this is the created product. So the ID is 11, and also we have the date. Let's go to the previous tab, and let's read the details of the product with the ID 11. And you can see that we have this new product. So here we can see that the price is of type double. So instead of double, let's provide a string. Let's send the request. So this time we have bad request, but we don't have the validation errors. Instead, we have this exception. So to get rid of this exception, we have to read the price as a string, and we have to convert it into a double with ourselves. So this is product DTO. Let's declare the price as a string. Of course, we need to update the getters and the setters. So the getter will be of type string, and the setter requires a string. Let's save the file. Then in our create product method, we have to convert the received price into a double. So we can create a variable of type double, and then we can convert the received price, which is of type string, we can convert it into a double. If this works correctly, then we will save this price into the database, but if we have an exception, then we will add an error into this object, which is the binding result. So we will add an error of type field error. So it is an error related to the product DTO that we have here. The field is price, and the error message is the price should be a number. So if we add this error into the result object, then of course we will have some errors, and in this case we will return a bad request. Otherwise, we will store the price into the database. So just here we have product.setPrice. Let's delete this and let's replace it with price. Let's save the file. Then let's send the request again. So this time we have this validation error. The price should be a number. So let's provide the correct price. Then send. And here we can see that we have a new product. Now let's create the method that allows us to update the products. We can call this method updateProduct, and it returns a response entity of object. So this method will be accessible at the URL of this controller, which is /API/product/the product ID. So it will be accessible using the HTTP put method. It requires the product ID that is available in the URL, and also it requires the object of type product DTO in the body of the request. So we will validate the submitted data, and the validation errors, if we have any error, will be available in this object, which is of type binding result. So here we will read the object product, which is of type product, from the database using our repository. We will pass the product ID to this method, find by ID. If we have the product, then product will be the product in the database, else the product will be null. So if product is null, then we will return not found. Otherwise, we need to convert the submitted price into a double. So we will convert the price of product DTO into a double. And if we fail to convert the price into a double, then we will add an error to the result object, which is related to the price, and we can write the price should be a number. Then let's check if we have any validation errors. So if we have any validation errors, then we will create a map using the error messages. And we will return a bad request that contains the different errors. Otherwise, if the submitted data is valid, then we have to update our product. So we will update the product name, the brand, the category, and the description using the submitted data. And for the price, it will be the converted price. Now let's save this product in the database. So we can use our repository. Then we can return a success response that contains the updated product. Let's import this annotation and let's save the file. Let's open a new tab. So we will send a request using the put method. So we can copy the product details from here. Let's provide the URL of the server, which is /API/products. Then let's select body, then row, and we will send JSON data. So of course we have to provide the product ID. So we will update the product to the ID 12. Let's paste the object here. So this is an object of type product, but we will submit an object of type product DTO. So let's delete the ID. And let's delete the date. Of course, we have to delete this comma. Then let's update the name. We can also update the price. Then send. So here we have a success response. And this is the new product in the database. So we have a new name and we have a new price. Let's provide a price which is not valid. Then send. So here we can see that the price should be a number. Now let's create a new method that allows us to delete products. We can call this method delete product, and it will be accessible at the URL of this controller, which is /API/products/the product ID, and it will be accessible using the HTTP delete method. So here we will read the product ID from the path, and we will read the product from the database using our repository. So if we did not find the product in the database, then we will return not found. Otherwise, we will delete the product using our repository, and we will return a success response. Let's import this annotation, and let's save the file. Let's open a new tab. Let's select the delete method. So the URL will be /API/products, and then we have to add the product ID. So let's delete the product to the ID 12, for example. So first, let's take a look at the product to the ID 12. Then send. So here we can see that we have this product. Now let's delete the product. So here we have a success response with no data. Let's see if we have this product or not. So now we have not found. Let's delete the same product again. And this time we have not found because we already deleted this product.